Hi, welcome to Code Cadence. My name is Saim. In this tutorial, we will understand the basics of algorithms. In this tutorial, we will cover the following topics, such as what is algorithm and its inventor, why we need algorithm, how algorithms work, the use of algorithms, algorithm efficiency, and some examples of algorithms. What is an algorithm? An algorithm is a step-by-step procedure or set of rules for solving a problem or performing a task. It used in computer science, mathematics, and everyday life. For example, a cooking recipe is an algorithm for preparing dish. Let me give you a real-world example to better understand algorithm. For example, pommet fries recipe. First cut potatoes, leave them in water for 10 minutes, then dry the potatoes, and then boil them in hot oil at about 300 degrees Fahrenheit or 150 degrees Celsius for about 3 minutes. Now it is ready to serve. Now you know how we are using algorithm in real-world scenario. Who invented algorithm? Muhammad ibn Musa al-Khwarizmi is the inventor of algorithm. He was a Persian mathematical genius. He was born around 780 AD in the region known as Uzbekistan. So you might be already thinking what algorithms are doing. Algorithms are essentially sets of instructions or rules that we already know from the previous slides that guide how specific tasks are performed. They are at work behind the scenes in almost every facet of modern life. Here is what they do. Process information. Algorithms analyze data, recognize patterns, and provide insights. For example, weather prediction systems use algorithms to process atmospheric data and forecast conditions. Make decisions. Many algorithms make decisions, from recommending movie on streaming platforms like Netflix to provide loan applications. Automate tasks. Algorithms power automation by handling repetitive and mundane tasks like sorting emails into folders or managing inventory systems. Solve problems. Complex mathematical or computational problems like finding the shortest route on a map are tackled by algorithms. They are the engine behind software, shaping how machines interpret and interact with the world. Here we will see some characteristics of algorithms. First, well-defined inputs and outputs. For example, we have two numbers, say A and B. We have output, the sum of these two numbers. For example, A plus B. Definiteness. This means each step of algorithm should have clear and unambiguous. In this case, for example, take a first number A and take the second number B. Add A and B to get the sum. Output the result. Every step is clear and leaves no room for interpretation. Effectiveness. Each step must be basic enough to execute. In this example, taking inputs, adding numbers, or displaying outputs are operations that can be easily performed by a computer or a person using a calculator. Finiteness. The algorithm must terminate after a finite number of steps. Here, the process concludes immediately after providing the sum of A and B, ensuring the algorithm doesn't go on indefinitely, right? So we need an output, so it has to be finite. Correctness. The algorithm should produce desired output. If you input A is equal to 3 and B is equal to 5, the algorithm calculates 3 plus 5 is equal to 8, which is correct. Here we will see some algorithm examples. For example, finding the fastest route in a GPS navigation system. So if we use, for example, Google Maps. So if we search, for example, any location you might think now, so you want to go from A to B, so it will find you the easiest, shortest route and the more convenient route based on the algorithm. navigating an airplane or a car, for example, cruise control, finding what user searches on the internet, for example, using Google or Bing, Yahoo search. Sorting, for example, you are looking for a movie in Hulu or Netflix, so you want to sort it by rating, so there's an algorithm too. Data structures together with algorithms. Data structures and algorithms go hand in hand. A data structure is not worth much if you cannot search through it or manipulate it efficiently using algorithms. And the algorithms in this tutorial are not worth much without a data structure to work on. DSA is about finding the efficient ways to store and retrieve data, to perform operations on data, and to solve specific problems. By understanding DSA, you can decide which data structures or algorithm is best for a given situation. Make programs that run faster or use less memory or both. Understand how to approach complex problems and solve them in a systematic way, which are really important on your software engineering or developer journey. Here's a quick breakdown of each. Decide which data structure or algorithm is best for a given situation. For example, if you need fast lookup, using a hash table is ideal. To store and retrieve contact names by phone number efficiently, make programs that run faster or use less memory, or both. For example, sorting larger datasets. Merge sort can reduce time complexity compared to bubble sort, and it processes data more efficiently. Understand how to approach complex problems and solve them in a systematic way. For example, solving a maze. You might use breadth first search (BFS) approach, which systematically explores all possible paths layer by layer to find the shortest route. Where is data structures and algorithms needed? Data structures and algorithms are usually used in virtually every software system, from operating system to web applications, for managing large amount of data, such as in a social network or a search engine, for scheduling tasks, to divide which task a computer should do first, for planning routes, like in a GPS system to find the shortest path from A to B, for optimizing process, such as arranging tasks so that they can complete as quickly as possible, for solving complex problems, from finding the best way to pack a truck to making a computer learn from data. DSA is fundamental in nearly every part of software world. For example, operating systems, database systems, web applications, machine learnings, video games, cryptographic systems, data analysis, and search engines. There are quite a few algorithms. Now we will learn the most common types, to those which are designed to accomplish different tasks. For example, sorting algorithms. Sorting algorithms are used to rearrange data structures based on comparison operator, which is used to decide a new order for data. Searching algorithm are methods used to locate specific elements or information within a structure or dataset. For example, search engine algorithm. This algorithm takes search strings of keywords and operators as input, searches its associated database for relevant web pages, and returns results. Recursive algorithm. This type of algorithm calls itself repeatedly until it solves a problem. Recursive algorithms calls themselves within a smaller value every time a recursive function is invoked. Graph algorithms are techniques for solving on-graph structures, such as finding paths, shortest route, or network connections. There is another very common type of algorithms we used in file encryption, which is called encryption algorithm. This computing algorithm transforms data according to specified actions to protect it. For example, a systematic key algorithm, such as data encryption standard. For example, it uses the same key to encrypt and decrypt data. If the algorithm is sufficiently sophisticated, no one lacking the key can duplicate the data. Greedy algorithm. This algorithm solves optimization problem by finding the locally optimal solution, hoping it is the optimal solution at the global level. However, it doesn't guarantee the most optimal solution. Dynamic programming algorithm. This algorithm solves problem by dividing them into sub-problems. These results are then sorted to be applied to future corresponding problems. Machine learning algorithms enable computers to learn from data, make predictions or decisions. There are different types of machine learning algorithms, categorized by how they learn: supervised learning, unsupervised learning, and reinforcement learning are some of the examples of machine learning algorithms. Brute force algorithm. This algorithm iterates all possible solutions to a problem blindly, searching for one or more solutions to a function. Divide and conquer algorithm. This common algorithm is divided into two parts. One part divides a problem into smaller subproblems. The second part solves these problems, then combines them to provide a solution. Backtracking algorithm. This algorithm finds a solution to a given problem in incremental approaches and solves it one piece at a time. Hashing algorithms. This algorithm takes data and converts it into a uniform message within a hashing. Randomized algorithm. This algorithm reduces running times and time-based complexities. It uses random elements as part of its logic. In this slide, we will try to understand algorithm efficiency. Algorithm efficiency is measured by evaluating the time and space resources required for the algorithm to solve a problem, typically as a function of the input size. The goal is to determine how well an algorithm performs as the amount of data or complexity increases. There are some key ways to calculate algorithm efficiency. For example, time complexity and space complexity. Time complexity. This represents the amount of time an algorithm takes to run, expressed using big O notation. For example, O(n) constant time, O log n logarithmic time, O(n) square quadratic time. It describes how the runtime grows with respect to the input size. For example, if an algorithm has time complexity O(n), its runtime will grow linearly as the input size increases. Space complexity. This measures the amount of memory the algorithm uses, also expressed using big O notation. It accounts for variables, data structures, and temporary storage required during execution. To calculate efficiency, we can follow these three steps, such as analyzing the algorithm, use big O notation, test empirically. What is analyze the algorithm? It breaks down the steps and identify how many operations or memory units are used for varying input sizes. Big O notation. Compare the rate of growth of operations or memory usage with respect of input size. Test empirically. Run the algorithm with different input sizes and measure actual runtime and memory size. Now we have come to the end of this tutorial. In conclusion, I can say that you have learned how algorithms play a crucial role in computing and problem solving. It also helps you to understand different types of algorithm and their efficiencies, which is essential on different part of computer science, application development, and problem solving. And we need continuous learning and optimization, which is the key to master algorithms. Thanks a lot for investing your time with patience. I hope you have enjoyed these video tutorials and learned the basics of algorithm. We will dive into more in-depth of algorithm in the future video tutorials. If you have liked this tutorial, then please subscribe, like, and share this tutorial. That will inspire me to continue making great tutorials for you.